All right, today what we're going to do is we're going to start 8C, look at 8C, solving problems involving reducing balance loans. Now, that is almost the exact title that we used on last lesson where we were building the schedule. The difference here is that when you have a very large loan to repay, or it's going to be repaid over a long period of time, then writing out a schedule of the payments is going to become really cumbersome. So instead, what we can do is we can use a formula to be able to find the amount or the balance or what's happening at a specific time. Okay? So what we're going to be doing is we're going to be looking for A at a specific time. And remember, anytime you see that capital A, that stands for the amount, the total amount, or in other words, the balance of the loan, right? That never changes. It's always the balance. So what we're going to do is we're simply going to take the future value, and you don't need to write this part down because you're going to use the formula. It's the future value of the loan is what we're looking for. We're going to take the future value without repayments and subtract away the total value of the interest and payments that you've already made. And what we're going to do is we're going to use a formula for it. And in order to use the formula, we need to know some specific information. Well, we already talked about A. A is simply the future value of the loan. And this is specifically a reducing value loan. Right? Reducing balance loan. Okay? All right, now, we also need N, and that is simply the total number of compounding periods. So, for example, if I compound for 4 years monthly, that's 4 times 12 or 48 compounding periods. Right? So be careful about when you have more than one compounding period. We also need I, which we know we've done tons of times. That's simply the decimal interest rate. Per period. And remember, the per period thing is important because if you're paying monthly, then that means you need to divide it by 12. If you're paying quarterly, divide by 4, etc. So watch out for per period. And here's something new, and they're going to flip-flop here. You're going to see back and forth with this. You're going to have capital M. Capital M is the same as capital R. Now, the reason it's different here, and they call it M, is because to find this, you're going to use not a repayment formula. Instead, you're using a formula that comes from annuities. And for annuities, they use capital M to represent how much interest and payments you've made or how much you've invested. So it's slightly different. You're going to see it as M. But again, the book is not very consistent. Every once in a while, they'll slip back to R. All right? So you have to recognize that R and M are the same thing. Well, the easiest way to do that is just remember that it's the only capital letters other than A that we use, right? Pretty much. Well, there's going to be one more, but one that you're very familiar with. All right? So, and that's simply the repayment amount per period. Again, everything is based on the compounding periods. Okay? And then finally, the last thing you need to have is P. And again, you've seen P plenty of times. What does P stand for? The principal. There you go. So what was the beginning amount of your loan? And so what we're going to do is we're going to look at this formula. You do not have to memorize the formula, but it's a combination of two formulas from your formula sheet. So what I'd like for you to do is get out your formula sheets so that we can look at these and find them so that you can mark which ones they're going to be so that you understand that you're going to be combining these two things. Okay? So A equals the compound interest formula minus that first annuity formula. The one that has an M in it, that starts with M, equals something? Yeah. All right? So, compound interest formula is easy. All right. Principal times 1 plus I raised to the nth power. We've used it over and over and over and over again in lots of different things. The one that's new is the annuities formula. And it's that first one. And you can tell which one you want to use because it looks very similar to the compound interest formula, the pieces of it. That specifically this piece of it. Okay? So, it's M, big bracket, 1 plus I raised to the nth power, minus 1 divided by I. Close your bracket. Now, it is not a pretty formula, but it's not difficult to use because your calculator can do all the work for you. But I am going to warn you that your calculator, for most of you, can't do this in one step. If you're used to entering the whole formula using a bunch of brackets or whatever and then just using your calculator to compute these, you can give it a shot. Some of the scientific calculators can make it work, but different ones that are the exact same brand, etc., will not let this work. It's just something that is a quirk of your scientific calculator. They're not supposed to be able to do anything that sophisticated and shouldn't be able to anyway. Now, so that means you're going to have to make sure that you save a lot of decimal spaces. Now you can do this part and this part in one step and then simply subtract them. That'll work on all of your calculators. But be careful. If you try to enter it all, just make sure to check to see that it's working if you're one of those people that enters it all at one time. Okay? And if you're not, then make sure when you save it, you save lots and lots of decimals. Because if you round too early, don't round it to 2 decimal places or something silly for early, because if you round too early, you're not going to get the right answer. Right? Leave like 6, 7 decimal places or whatever it has, because you're going to need them in your computations. Okay. So let's talk about our steps. First, you're simply going to write down the values for P, I, which you will have to compute, right? Because I's, you need to make sure it's per period. Your R or M, and I'm going to write both of them down there because, again, they flip-flop. And you will too, probably. And you need to know that they're the same thing anyway. And your N. But remember, N is the total number of periods you're compounding for in this thing. So don't think of it as 1 year unless the question is in 1 year. If it's 5 years, then you're going to have to multiply times 5, right? Make sure you have all of them. Okay? Second, just apply the formula. Just by substituting the values and then simplify. Now again, remember that for most of you, your calculator can't do it all in one go. You're going to have to do it as 2 different pieces. And finally, just write out your answer. Answer the question that's being asked, because sometimes you're going to be looking for the amounts, sometimes you'll be looking for the principal, sometimes you'll be looking for payments. And remember, always round to the nearest cent. Okay? All right. So let's look at an example. Now I'm just going to make the list. Let's say that someone borrows $8,000 and they borrow at 11.28% compounded monthly. they do a repayment amount, so an R or an M, whichever you prefer, of $500 per period, so $500 a month. And they're going to do that for 1 year. We want to find out the value of the loan after 1 year. Okay? So, first of all, I can't leave I as a percent, so I need to change it to a decimal, so that's 0.1128. And since it's monthly, I will divide it by what, guys? 12. And that gives me 0.0094. And if she's going to leave it in there for 1 year, and it's compounded monthly, that's 1 times 12, or 12 compounding periods. Okay. And now it's simply a matter of plugging it into the formula. We are looking for A. We don't have our A. We don't know the future value of the loan. So that's the thing, that's our unknown. So we're just going to leave it as A. Pay attention, though, because you're not always going to be looking for A. You could be looking for principal, or you could be looking for the payment amount. So A equals 8,000 times 1 plus 0.0094 raised to the 12th power. Now, that's just the compound interest formula, right? Putting in the principal, 1 plus my interest raised to the nth power, minus my payment amount, which in this case is $500, bracket, big bracket, and in the top, 1 plus 0.0094 raised to the 12th power, minus 1, all divided by my I, which in this case is 0.0094. So all I've done is substitute the right values in the right places in the formula, making sure, I forgot to close my bracket there. Making sure that you have every piece where you need it to be. Now, you don't have to. You could have done that 1 plus business if you wanted to, but it would be safer for you, and when I'm grading these or marking these, it would be the safest bet would be to write out all of that. I never know what little piece they're going to want for me to give credit, to give full credit. So it's safer just to write out any formula that you need to use, just put in every piece of it, and then start simplifying. Once you start simplifying it, then I'm not looking so much for the work, but I need to see the initial formula. And then you can put in answers. The calculator can do the rest. But if you just put in answers without writing the initial formula, I cannot give you full credit. Make sense? All right. Now, your calculator can do this bit, right? And we've done this 1,000 times. First, you do what's inside, so just add those together. Then you raise it to the 12th power, and then you multiply it by 8,000. So we plugged in all our values, we simplified it using the calculator, and then we rounded the final answer to 2 decimal places. Okay? Again, if in doubt, hit enter after every single operation you do. It will never make it wrong. Okay? The more times you hit enter, the more likely you are to get it correct, get it right. It's actually the way it works. All right. Now I want to look at another one. Here we have somebody who wants to borrow some money. What is it called when you borrow money? That's the what? The loan value, the initial loan value, which is called the principal. There you go. So this person just wants to borrow some money. Do I know how much money? No. Okay. But she wants to pay it off in 2 years. So that means after 2 years, she doesn't want to owe anything. The bank is going to charge her 3.48% interest compounded monthly. And she's going to make monthly payments of $600. So there's our scenario. She's going to borrow some money. She wants to pay it off in 2 years. There's her interest rate, and there's her monthly payments. So, at the end of the loan, what is the future value of this loan if she wants to pay it off? 0. She won't have a balance at the end of the term, right? So in this case, she wants to pay it off completely. So that means 0 for that, okay? All right. What is the principal amount that she wants to borrow? We have no idea. So that's our unknown value. Okay? All right. Then, she's going to keep that. We need our interest rate. It's 3.48% monthly. So that's 0.0348 divided by 12, which is going to give me 0.0029. Okay. She's going to pay it off in 2 years, monthly. So that's 2 times 12, or 24 periods. Good. And her payment amount, R or M, whichever one you're using, is $600. All right. Now, I'm not going to take you through the calculator part of this. I just want to simply take you through the part that you need to solve. So what we're going to do is fill these values in the formula. So A equals P times 1 plus I raised to the n minus M times 1 plus I raised to the n minus 1 all divided by I. A is 0. We don't know the principal amount, but it's times 1 plus 0.0029 raised to the 24th power minus her payment amount times 1 plus 0029 raised to the 24th power minus 1 all divided by 0.0029. Okay. Now, here is my unknown value. I can't solve for P without first getting the P term by itself. So remember, just basic algebra. If I want to get this by itself, then I need to move this stuff first. Well, that's all one term. So how do I move subtraction? I'm going to add it to both sides. But when I add that to 0, it just gives me 600 times all that stuff. Now, you could simplify it first if you want to. But I'm not, just in the interest of the notes. All right? Then, how is that P attached to the other stuff? What operation? Times. And the opposite of multiply is divide. So I'll just divide by the stuff I want to move. And now, if that's going to divide away, then I just have to simplify this thing. All right? Simplify the top of the big fraction, divide it by that bottom part. I would simplify the top, simplify the bottom, then divide the two answers. Whatever you want to do, doesn't make any difference to me. And if I was going to do that, this is easier to simplify. I'd simplify that one. Then I would simplify this one, and then I could just do answer divided by the bottom, that other number. It's a lot easier, a lot less to push in. Makes no difference to me how you simplify it. There's 1,000 different ways, orders you could use. Makes no difference to me. Do what you want to. Okay? Now, what if I was solving for M? Think about it. You have A equals P times a bunch of junk minus M times a bunch of junk. If I wanted to solve for M, I don't like minus M, right? So what I could do is simply add this over here, which would be fine because in order to do that, A has to be 0. You want to pay it off loan. You just want to find out what payment you're making. So you would add M to get it by itself first, then divide to solve, right? Get the letter you're trying to solve for completely by itself. Now, you could have moved the other one, but then you would have negative that one equals negative the other one, which you could then just change to both signs. It doesn't matter. But using just basic algebra skills. Right? Okay. There you go.